Good morning or good afternoon, everyone. Thank you very much for joining us for this webcast on how to future-proof legacy data from IDMS business systems. My name is Raluca Petrescu. I'm a digital marketer at Anubex, a leading company in application modernization that recently joined Astadia, a global service provider, to form a complete mainframe application to cloud platform. For today's session, we have invited 3 experts to share their insights on IDMS modernization options and approaches and available software tools that can be used in successful transformation projects. And we also have 2 examples of such projects. So I'd like to welcome Louis Heymans, Managing Director at Anubex, who has extensive experience in building business operations and developing high-performing migration solutions. We also have with us Amir Tal, IT Project Manager, who's going to give an overview of the mainframe modernization project he led at the telecommunication company Bezeq in Israel. And along with us, we'll have Craig Story. Craig is the Chief Commercial Officer at Atlantic Lottery in Canada. But today he's going to showcase a modernization project implemented by the government of Alberta, together with Mariner Partners, where he previously acted as Executive Vice President for Global Sales. Before moving on, I would like to invite you to leave any questions you might have in the questions box, and we'll do our best to address them at the end of the session or in a follow-up email. That being said, I'd like to invite Louis to open the discussion and perhaps explain a bit why IDMS migrations are a hot topic these days.
Okay, hello everybody. Can you see my presentation, Raluca?
Yes.
Okay. So my name is Louis Heymans. I'm the Managing Director of Anubex, but Anubex now, in fact, is Astadia. We merged 10 weeks ago. So although on certain slides you might still see the name of Anubex, we are Astadia. Okay. I'm with the company for almost 30 years. So during that time, I encountered a lot of companies with different technologies. And lately, it's very clear that a lot of people using IDMS systems are looking for solutions to get out of this technology. My first few minutes is about why migrate from IDMS and why now. So wherever we go or whenever we speak to people with IDMS systems, it's clear that we're not speaking about systems that have been developed yesterday. And it's also clear that these systems still support core business. Now, when you want to replace this, what we also found out is that there are no commercial off-the-shelf solutions for this type of business or applications. And in many cases, they are too big to redesign. So the real solution, in fact, is to do a one-on-one migration to preserve the functionality and to remove the dependency on IDMS. Now, we have been talking and dealing with companies that first tried to redesign many years ago. Some of them spent millions of dollars, and then in the end, finally, they came to us to help them out and migrate them away from the IDMS. IDMS is a pre-relational database. So at the time when people developed applications that dealt with a lot of data and needed to be performant, they typically would go for systems like IDMS. So at that time, it was a perfect fit for applications which required a lot of data. But at this moment, IDMS is really suffering and has a problem to support the exploding amount of data that we see today, especially in those companies where we have discussions with. And what we see is that today the relational databases that are available on the market, they provide more than sufficient performance, and they even outperform IDMS And of course, they scale much better than IDMS does on the mainframe. And yeah, well, I think it's not a secret. The people that developed IDMS systems, they started these developments 40, 30 years ago. And yeah, there is an aging staff there. So when we speak to people, we see that most of them are close to retirement. And sometimes we deal with the migrations where people that are still working in the project are in fact already retired. So this means that the application knowledge disappears, which is a problem in itself. And so far, I've not yet seen a tool that solves the aging problem. Another thing is flexibility. Of course, you can integrate IDMS with certain tools, modern tools on the market, but that is quite complex. So it is difficult to integrate IDMS applications with something like analytics support, for instance. And of course, IDMS doesn't run in the cloud. That's also a shortcoming. And then remarkably, well, maybe not remarkably, the rapidly decreasing community. When we say less than 1% of all database technology, then we're talking about all the pre-relational databases together. And that's not only IDMS. IDMS is only a fraction of that. Together, they represent less than 1% of all the database technology that is in use today. No more new features are built into IDMS. And if you are the last one on the train or on the bus, you will pay the full fare, we suppose, we assume, and maybe more. And today, we are talking to large organizations that use IDMS, and they all are already starting migrations or are planning to do migrations. So you do not want to be the last one, I suppose. So to recap, we're talking about old systems, but still supporting the core business. They are not relational, these databases. Okay, some provide some SQL support, but they're not really relational databases. We have aging staff, lack of flexibility, and rapidly decreasing community. For you who are Gartner customers, Gartner recently released a study about the pre-relational databases, among which, of course, IDMS. And in fact, that's where I got a figure of less than 1% from. And it's very clear, their message is very clear. It's now time to leave, or at least to plan to leave IDMS. Okay. Now, when you want to get out of the IDMS technology, you have two options, or you can stay on the mainframe. You can remove all the IDMS, or some call it CA technology tools, or you can go to a distributed environment or to the cloud. Now, when you stay on the mainframe, then it's not very invasive. Well, invasive means that a lot of things you just do not touch, like authentication through RACF, for instance, will maybe continue to be there. Your batch workload hardly changes, maybe except for some database utilities, IDMS database manipulation utilities that you will need to replace. Your online processes can move to COBOL KIX DB2, and the maps can be migrated to a 30-70 stream, in fact, running in the same or the existing terminal emulator, or even in a browser. Though two points that we need to stress is that if you stay on the mainframe, for instance, you move your IDMS to DB2, which is perfectly possible, but performance tuning will be required. The way IDMS approaches information is quite different from a relational database. So performance tuning is required anyhow, but if you work with the correct or the experienced consultants, then they will know how to do this tuning. So far, we always manage to get the same performance after the migration. And certainly there is a risk of MIPS increase. How much is difficult to predict? It's just, well, predict from my place here. It's just a matter of how the current application, how the workload is distributed over the processor, and what the frequency of accesses of the database. Short duration, depending on size, between 9 and 18 months. It all depends, of course. If you remove everything at once, in one go, then it can be done for, let's say, an average system in 18 months. Some people might want to move away from IDMS in waves or in steps. Okay. Now, if you go to a distributed environment, then, of course, everything changes. Most of the things change. For instance, authentication will not anymore be through RACF. You might go for LDAP or another technology. So there's more things that change. It could be, for instance, that you have printing on a mainframe that you want to change to another solution. So there's much more involved. Okay? But it is also an opportunity to move at the same time to object-oriented languages like C# or Java. And there is a wide choice of RDBMSs available, and certainly a wide choice of open source tools that allows you to do a lot of things like DevOps, which is easier than on the mainframe if you move to open systems. And you have the advantage of horizontal scalability, which by definition improves the performance, of course. And again, I was talking about a one-to-one migration. So it's more like a technical migration. But once you're off the IDMS technology, you can really start implementing microservices and things like that. And the medium duration, depending on size of such a migration, is between 12 and 24 months. Again, depending on whether you want to move in one, and the word is maybe not the right word or a scary word, big bang, or in a phased approach. Okay, now and that is where the strength of Stadia, Anibix Stadia is. Automation is the word that we use all the time. And why is automation essential? It's very clear. IDMS systems that have been built over the past 30, 40 years, they are large systems. And for us, what is an average system, for instance? I show some metrics there. Hundreds of files or IDMS records, more than 500,000 lines of ADSO, more than 5 million lines of COBOL, more than 500,000 lines of JCL. That is what we call an average system. Yeah. If you want to migrate that in a few months' time, having it up and running on the target environment, you need automation. You need tools that automate to a large extent all these artifacts, to transform all these artifacts. Moreover, testing should be largely automated. Yeah. If you can automate, and that's what we do, if you can, to a large extent, automate the testing, then you can keep the testing in a very small team. We use the method tracing on a real production environment or a reference test environment, and then replay. Now, the replay can be done over and over again by a very small team that even has no knowledge about the application. That makes the whole thing, the fact that the transformation of the components or the artifacts plus the testing to a large extent is a repeatable process and can be done in a very fast way. Now, Big Bang versus phased approach. Well, Big Bang, again, the name is a bit scary, but Big Bang has some advantages over phased approach, but in certain cases, There's nothing else possible than a phased approach. The Big Bang is, you work towards one moment where you switch everything at the same time to the new technology. When you do it in a phased approach, then it's maybe required to build bridges between old and new, and that will also take time. Now, automation means 100% automated, and what we mean by this is, and with this slide, I will end my presentation, but only look at the right-hand side, the column where we show the conversion rate or the transformation rate. There you see what we mean by 100% automated. And you will immediately say it's not 100%, well, it's 99. And okay, that is automation. If not, if you have to transform millions of lines of code, I mean, it will be difficult. You really need to go that far in automation. And with this, I would like to give the stick to Craig. Craig, please.
Okay, thank you. And good morning and afternoon. I'm just going to share my screen here, and hopefully this works. All these multiple platforms in this COVID world we're all getting familiar with. So hopefully you see that title slide. Is that correct?
Yes, we can see it.
Perfect. Okay. Well, just for a little additional context from what Raluca had shared at the time, my experience here with Alberta Justice and Solicitor General, I was the president of Mariner Innovations, and we were an IT services firm in Canada that was migrating its own business towards IT modernization. And we had been working with the government of Alberta for a couple of years before they issued an RFP. So my time there goes from early stages with Alberta to an RFP response to collaborating with Anabex, now Stadia, to deliver this program. So that's just a little more perhaps color commentary. So what this was the system join, which was the Justice's Online Information Network, was province-wide, and it was really getting quite brittle. And the client, Alberta Justice, was really quite worried about its future. And so the rate of change was on the increase, and they needed to migrate the platform. So basically, they went through a process and explored several options, and ended up with going through the Anabex factory, if you will, of migration tools and automation. The timing here was RFP issued in February of 2014, awarded in June, and the rehosted application went into production about a year later. So that provides a little bit of a thumbnail of kind of the what. As we a little bit more consistent, I suppose, with what Louis had talked about is the why. It might have checked many of the boxes that Louis finds in industry: that aging workforce, brittle platform, poor documentation, and an increasing rate of change being applied by the business that the technology team needed to support, and wasn't sustainable. So they went through a formal process, like I mentioned, in an RFP, and this is your typical checklist out of the RFP, and about any RFP. But perhaps more important is the informal and subjective elements. What is the least risk alternative? And taking the approach that was done was considered to be the least risk alternative because of the automation, because of the track record, and perhaps more so because of the testing capability. Many organizations that I have had the privilege of working with share one common deficiency, and that is test cases and documentation. And it's much like maybe in our own personal lives when we do a job, Could be carpentry, it could be anything. The job gets done, code gets developed, but documentation always suffers. And it's like putting your tools away at the end of a job. It's that last mile effort, because of demand and capacity are always out of whack. Documentation and test cases never become as rich as they probably need to be, just for the war of increasing demand. Now, what the test match was able to do was to really provide that testing utility and not rely on dated or out of date or incomplete or non-existent documentation. It provided a huge baseline for confirmation of the target environment. Another element here was the notion of like for like, wanting to ensure that what happened at the end of the day in the target environment was consistent with what was in production. And that's where, again, where automation is a huge enabler. And perhaps often underestimated is cultural fit of who you work with. And I think, that fit of personality and alignment to a cause is, a key criteria of success. And I think all those passed the gates for, at the time, Anabex and Mariner to be selected to do this project. So away we went. And basically, in summary, the best in class automation and testing capabilities were really put to the test. Again, testing. As Louis shared earlier, a very, very high degree of automation happened across the board. And it wouldn't have been possible to do this on the timeline or with a level of quality that was experienced. And here on the left, you'll see a little bit of the technical details of the volumes and the system attributes that I don't need to repeat, but I provide you that kind of context of how small, medium, or large was this relative to your environments. And then perhaps, I think this is my last slide, some challenges and lessons learned. Performance baselining is key to objectively measure target performance, and I think this is an area that might be often overlooked in terms of the baseline, because always having higher aspirations of faster, quicker systems, but the code base is the code base to start with. And what is its expected performance when we're trying to ensure a like for like replacement? There's certainly things you can do to tweak. Another aspect here, is version control. I think one of the challenges we had in this project was because the business was demanding new changes and needing to have that agility, there was scope creep, there was time creep of version control of, okay, we got to make this change, we got to make this change. Well, when you're using automation tools, you do need to draw a line in the sand to say, we really have to have a code freeze to get over this hump. Otherwise, it'll be a death of 1,000 cuts, and that'll elongate your cycle time. But it takes some courage to know when you need to make that kind of change or make that kind of commitment of time. The next piece here is, sorry, I lost my mouse, is the infrastructure environment. Here we're talking about the code, the database, etc. But this is a system change, there's many components to ensuring a complete platform change, and the infrastructure cannot be overlooked. And one of the challenges that occurred in this one was this was a brand new infrastructure environment that had been developed, and this was the very first business application going into a new data center. And it wasn't tuned, and it wasn't ready. And that introduced needless delays, and also some stress, because there was very different environments from dev to UAT. Staging was another one, and production environment. The four environments were vastly different, and not a best practice when you're trying to test for completeness and readiness for production, and that caused some needless delays. And again, automation and testing, the capabilities are integral to ensuring success. So this migration factory out of Astadia and Abex, it just simply worked. And there were several components that were utilized on this project. Code turn, data turn, test match were all components of the factory that were materially engaged to reduce the risk and to deliver the solution. And I don't think there was maybe an appreciation for the value of some of that at the early outset, but it was definitely proven. And then finally, every project has challenges, and perhaps this is where it comes to a cultural fit. And because when we were running into some of these issues of lack of code freeze and infrastructure environments that weren't stable and consistent, many vendors might just say, well, that's it. My job was to get this code delivered. Well, that would have been true to the law, but not true to the intention. And the intention was a successful migration. And that means going from whatever platform you're on to in production and in business. And it's those hurdles and challenges that test the relationship and test the commitment and test the culture. And I think my experience working with Louis and team was just simply stellar. There was issues, but there was never ever any finger pointing. It was all about leaning in to figure out how are we going to get through this and get the client where it needed to be. So that was my experience. It was delightful and not without its tests, but it was certainly successful. And that would be it for me, I think. And back over to you, Louis or Raluca or Amir.
Thank you very much, Craig. Yeah, this was very insightful, especially the challenges and lessons learned section. I think it can provide a lot of value to any team preparing a similar project. And since some of these challenges might be specific to government agencies, I think we have the opportunity to see how a similar journey can look like in the private sector. So I would like to give the floor to Amir, who led the modernization project at Bezek.
Okay, hello everyone. Let me just bring up my slides. Okay, so my name is Amir. I was the project manager for the migration project at Bezek. Bezek is the largest Israeli telecommunications company. So just some background. Originally, all of Bezek's IT systems ran on an IBM mainframe using the IDMS DB and DC. And they were divided into three major lines of business, as is listed here. I will focus on the last one, which is order management and fulfillment, the OMF, which was done by code migration. Bezek's IBM mainframe was at about 1,000 MIPS. We had just over 5 million lines of code and 1,000 batch processes, 2,000 concurrent users. I think it's the average project that Louis referred to. So during the 1990s, Bezek decided to migrate all its systems. Back at that time, we had no idea that code migration is possible. So we used a traditional approach of buying commercial off-the-shelf products and tuning them and developing them. So two of those lines of business were migrated using COTS products, and these projects were really mega projects. They took about 5 to 10 years each, costing tens of millions of dollars. So we were left with the last system, which is the OMF, and we started doing this with the traditional approach. But after 1 year, we reached this idea that it's not going to end on time or on budget. And the management decided to stop the project and start it again using the one-to-one code migration. The objectives you have already seen in the other presentations. I would like just to focus on two of them. One is the significant maintenance lowering. We calculated that the ROI of this project would be just over 2 years, and it turned out correct. Another objective was to lower our dependence on IDMS professionals. During that time in BESIC, there were very few IDMS installations, so very few people who understood the IDMS in Israel. Okay, so the timeline of the project was actually at the day that the management decided to stop one project. They decided to run with the new approach, but they required us to keep the original time of the project, which would be to shut down the mainframe by the end of 2011. That same day, we started writing the RFP. So it was very dense, maybe, project. We started writing the RFP, and it took us about 6 months to select a vendor, which I will describe a little right now. And we started the project by June 2010. We finished it, and we shut down the mainframe on March 1st, 2012, which is a 2-month delay, but still on budget. So selecting the vendor, we made a list of 7 groups, and we asked them to provide an option for 2 target architectures, one based on Microsoft, the other on Oracle. And this coincided with a parallel process by the procurement department for the renewal of the maintenance agreement with both companies. So having such a big project allowed us to make some leverage in this area as well. Then we continued with a short list of 2 companies, and we visited their clients abroad, and finally selected the Anubex, both by the technical team and the financial team. Okay. So I would like to describe our main concerns before the project began and see what happened with them, and then to describe what really happened during the project. So before the project began, we were extremely concerned about performance, both for batch and the online. The other one was the phased rollout. Are we going to do a big bang or a phased? We decided to go with a big bang. Cutover planning was also very difficult. Basic systems work 24/7. And we're not allowed to do any work on Saturday, meaning that it really makes the cutover very, very short. There was a question about rollback. We decided that we're not going to plan for any rollback after the switchover, only if we fail during the switchover itself. But afterwards, we decided not even to plan for one. As was mentioned earlier, we were not sure that we had all our source code. The system was very old, very poorly documented. So this was another concern. The same goes for test scenarios. We had very few test scenarios for the online, and none at all for batch processes. Another one was the development cycle, which we had to continue developing throughout the duration of the project. We were not sure how this would work during such a project. And the last one that I noted here was how would our internal teams cooperate with Anubex, since they were, afraid they may lose their jobs at the end of such a project. But all of these turned out to be okay, mainly because we had I think, a good mitigation plan. And of course, Anubex experts, their methodology, and the tools that they brought to the table. And I would like to note especially the automated test tool, which helped us overcome the issue of the scenarios that were not that did not exist. The last slide, I would like to explain about some surprises that we encountered during the project and the difficulties. So first of all is the batch testing. We late at the project, we came to a conclusion that we could not use an outside team to test all our batch processes, and we had to rely very heavily on our development team. Another one was that we found out that we gave Anubex a wrong set of source code for some of our screens, and this was also discovered quite late in the project, but somehow they were able to overcome this. The performance, of course, well, here we found that out of those 1,000 batch processes, only 10 of them were found to be slower than on the mainframe. And some of those 10 were a big problem, so we did have to modify and rewrite parts of those batches. Integration is always a problem, but we found that here, especially in some applications where we had screen scraping, we had an issue with that. And another surprise is the batch scheduling. Both systems, the Control M, the mainframe and the open system, we already had Control M. So we thought that this would be like a walk in the park, but it proved to be quite difficult because of different versions on those platforms. And last was the reports migration. This was done by a third company, and it turned out to be quite an issue. So that's all. Thank you.
Thank you so much, Amir. Actually, just in time, because we're getting closer to the end of the session, and we also have a few questions. So I would like to invite our guests to maybe pick up some of the questions we have in the box, in the question box. I think the first one is related to the examples of the case studies we've been talking about. The examples only relate to a migration from mainframe to cloud. Are there examples of a migration where the application stays on the mainframe?
Can you hear me?
Yes.
Yeah. Well, yeah, we have done IDMS migration staying on the mainframe, and currently we are about to start a large migration for one of the largest car makers in the world, and maybe also one of the largest IDMS users in the world. And we will migrate them from IDMS to COBOL Kix DB2 on the mainframe. For the Ministry of Finance in France, in 2005, we did a large migration, also staying on the mainframe. So we have examples of companies that stay on the mainframe. Also for other technologies like Société Générale, the large French bank, there we migrate Arabas Natural to COBOL XDB2, also staying on the mainframe.
Okay. There is another question for Amir.
Size of the IDMS database in BESEC. Do you remember that, Amir?
I will answer this. So we had this, the IDMS database had 2,000 records. I don't know its size in gigabytes. I don't remember it. We had just over 5 million lines of codes, 1,000 MIPS for the production environment, 200 for the test environment, and that's it.
Okay.
Thank you. And there's a question about code turn. Louis, I think this one is for you. Does code turn support the retrofitting of code to allow business change to continue during long transformation projects?
No, it doesn't support retrofitting code. No. But just maybe one thing. Maybe just now that I read the question again. So during the transformation project, people just continue to develop in IDMS. They don't need to stop developing because, as I said, it's a fully automated or a largely automated process. So from time to time during the project, suppose a project takes 24 months, then during those 24 months, we will at a regular basis refresh what we call a snapshot with which we work, meaning that we take the latest components that represent the system that is at that moment in production. So, in fact, Amir touched it a little bit, or Craig. You can continue to work, develop until very late in the project. So usually there's a code freeze of 4 weeks. More code freeze for data structures than for code itself. But let's say you have to take some time. But even then, customers continue to develop because we do not only migrate the production environment or sources that represent the production environment, but we also migrate the development environment. Of course, you don't need to test it because it was not tested yet on the mainframe. So we migrate the development environment, and so there is no reason to stop developing during the migration project. Only for what is in production, we ask people not to put new things in production, let's say the last days before the go live.
Thank you, Louis.
There's a question about what are the prerequisites to develop a migration scenario solution. Usually, if we are in contact with people that are interested in knowing how this works, the first thing we do is we send, of course, we talk about what the expectations are. And in order for us to give, in a very short time frame, a kind of rough order of magnitude in terms of what could it take in terms of money and resources, with a completed questionnaire, we can give this. Of course, if people really want a fixed or a real proposal, then we advise people to do an assessment. And an assessment that, depending on the size of the system, can take between 6 weeks to 3 months, 6 months, depending on the size of the system. And then we will provide a fixed price, fixed time frame proposal for the migration of IDMS.
And I think we only have time for one short answer, so perhaps we could take one more question and then wrap things up.
There is an interesting question about reducing the use of MIPS by using the ZIIP processor. Yes, that's a possibility. Yeah, you could move some workload to the ZIIP, whereby you also reduce cost and of course MIPS increase. Yeah. If you stay on the mainframe, definitely there will be MIPS increase. How much just depends on the system that you use currently.
Thank you, Louis. And unfortunately, I think we have to end up the session here. But I would like to thank our speakers once more for taking their time to be here with us and share their insights, and invite you all to visit our websites for more resources and maybe to get in touch with our experts. So thank you all so much, and I hope we'll see you to our next session. Have a good day, everyone.
Thank you. Bye.